Alrighty. So, really tired. Been a long day, long week, but we are going to try to knock this video out. So this is our first lesson in Unit 3 this year, solving quadratic equations with square roots, and we're going to introduce the concept of I in this lesson, and then we'll build on the concept of I in the next lesson. So before we launch into that, I do want to quickly review what does it mean to solve an equation. One thing I notice is that a lot of students tend to use the word solve or solution when it doesn't actually apply. So to solve something doesn't mean the same as to answer it, at least not in math class. It doesn't. Solving an equation or the directions to solve means something really, really specific. And what they mean is to find the value or values of x that will make the equation true. So that is like a really, really, really specific definition of what it means to solve something. So to find the values of x that will make it true. Now, for example, what I'm going to do in class, so if you're watching this because you missed class, you can kind of pause the video and do this on your own. But I want you to explore, is x equal to a solution for 2x squared minus 3x plus 5 equals 7. So play around with that. Okay, use the definition of what a solution is to try to figure out if it makes it true. Right, I hope you did that. I hope you paused the video and tinkered with that, because that really is a valuable part of the learning experience, is you handling and exploring and you making those connections for yourself. So what we're going to do to figure out if this is a solution is turn on the pen. I'm lucky that did not advance the slide. Okay. So we're going to plug in 2 times 2 squared minus 3 times 2 plus 5. And what we want to know is that equal to 7? So remember, when you're doing this, that you do want to use order of operations. So order of operations, I'll kind of put them at the top. You do any parentheses, and then you do exponents, and then you do multiplication and division left to right, and then you do adding and subtracting. So sorry, it's really messy. That's parentheses, exponents, multiplication, division, like they're lumped together, and then adding and subtracting lumped together. So I don't have any parentheses, at least not that I can do anything in. But I do have an exponent. So we're going to do that first. So 2 squared is 4. And now we just have multiplication and adding, subtracting. So we can basically at this point go and do all the multiplication there. So we can do 3 times 2 is 6. And then as we're working that out, we want to bring that down. 8 times 2 is 2 times 4 is 8. All right. And then we do adding and subtracting from left to right. So that's a common misconception, is that you do adding first. We have to write one of them first. So we just write adding first, but they are actually the same operation. When you think about subtracting, means adding the opposite. So we actually do them from left to right. So we have 8 minus 6 is 2. And then we have 2 plus 5 is 7. And so I land at 7 equals 7, which is true. So the answer to the question is yes. Now, I was actually kind of surprised when I was working that out in my head earlier, because I really did make this up like off the top of my head. And the chances that I would make one up that would be true are kind of slim, but it didn't matter for teaching purposes if it was true or false. Like, we just answer yes or no. Now, that just is to review what it means to solve something. This is what we're looking for. Now, what I did right there wasn't really a solution. This was more of a check. Okay, so you had a proposed solution and you wanted to check to see if it was a solution. That's not the same as carrying out the steps to find the 2 in the first place, which is what we will be studying in this unit. Now, a quadratic is characterized by its x squared. That's the thing that we look for to determine if a particular function is quadratic. So I want you to think for a moment, how can we undo squaring? Do we have an operation that undoes that? Think for a moment. All right, so you might have thought of this, the square root, okay? And the square root is different from squaring, okay? So I'm going to be really clear about that. That is to square something. Okay, this is to square root it, and we do want to get the vocabulary correct. So we don't want to say square when we mean square root, and we don't want to say square root when we mean to square. But essentially, square rooting undoes squaring. So that's another operation we can carry out. So if you see something squared, and you're like, I don't want it squared, I would like to unsquare it to get just the x, then we can use a square root to do that. Now, this will work with some quadratics. So as we go through the examples and stuff, I want you to be on the lookout for when you think it works or when you think it doesn't work. All right. So just kind of, I want you to plant that seed in the back of your mind as we go through this. Okay. So example number 1, we have x squared minus 16 is equal to 0. So for this, we're actually going to work this strategy the same way we would work a linear equation, which means we're going to try to get x by itself. So to do that, I'm going to add 16 to both sides, and I will get x squared is equal to 16. Now, from here, I want you to keep something in mind. Now, from here, you might get the answer. Okay, you might be like x squared, what times itself gives you 16, and you're probably already thinking of a number. Okay, so you might be thinking 4, but I want you to keep this in mind. Yes, it is true that 4 squared is equal to 16, but it is also true that -4 times -4 equals 16. So that means there's actually 2 solutions to this, +4 and -4. So when you go to take the square root, okay, this used to bother me so bad when I was in high school, okay, just stuff that bugged me because I didn't really get it, okay. When you go to take the square root, you must put plus or minus in front of the square root. The reason is because there will be 2 numbers that will give you that squared, that number, okay? So it would be both the 4 and the -4. The square root of x squared is just x, so that undoes the squaring. And now over here, we would do the square root of 16, and that gives us 4. And then when we do that, we have that plus or minus, and that's our little reminder that both the +4 and the -4 work as possible solutions, okay? And so we have now solved that quadratic equation, and we used a square root to do it. On to the next. So this one's a little bit messier, all right? But we're going to try the same strategy. We're going to try to get the x squared by itself. So we will start on this one by adding the 10. Okay, so we have 2x squared equals 50. And then we will divide by 2. So 2 divided by 2 is 1. So we end up with 1x squared. 50 divided by 2 is 25. And now I've got that x squared by itself. So I can undo that x squared by square rooting. When you take the square root, though, you need to remember that plus or minus. The square root of x squared is x, and then we've got that plus minus, and then we just do the square root of 25, which is 5. And so we have 2 solutions again to that one. We have +5 and -5. Now, not all quadratics are going to come out this way. This is kind of a unique case, but it is one that we want to explore so that you have this tool in your toolbox for solving quadratics. And without further ado, let's take a look at another example. Can we use a square root to solve this one? Explore before you answer. So this is another one. I want you to try to explore it before you answer. Can we use a square root to solve it? All right. Now, I hope, again, that you did this. I hope that you actually paused the video and explored with this. So what you might have done is you might have tried to get the x squared by itself. So maybe you added 4 to both sides, and maybe you subtracted 3x from both sides, and then you tried to take a square root, and you're like, but here's the problem. Now you've got x equals plus or minus the square root of 4 minus 3x, and you still have an x on the other side. You're like, okay, that maybe didn't work. Maybe that's one of the things you tried to do. Maybe you tried to keep all the x's together. Okay, so you might have tried this. So maybe you added the 4 to both sides, and you had x squared plus 3x equals 4, and then you tried to square root it. And so, and at this point, I want to be really careful about what I write on the screen, because I don't want to write something that's algebraically impossible that you might have written, but it would be algebraically impossible. You got the square root of x squared, and maybe you said that was x. Now we actually can't do that, but I don't want to open that can of worms right now. Even if you did that, though, you would end up with a square root of 3x. So you would still have that other x over there, and it would be under a square root, which you don't want. Okay, and what I hope you noticed as you were exploring, and again, we want to explore this, is you come to this conclusion before I put it up on the screen, because you are way, way, way more likely to remember it if you did the exploration and you kind of saw what went wrong with it. So the conclusion is we can only use this strategy when b is equal to 0. So just to clarify what I mean by that, in your form of a quadratic equation, right? So you've got ax squared plus bx plus c. If b is equal to 0, then you have ax squared plus 0x plus c, and 0 times x is just 0. And so you end up with ax squared plus c. The presence of the x renders this useless. So if you see an x squared, you're good. If you see the x squared and also an x that's by itself, you cannot use this strategy to answer it. So is that a lot of, equations that you can't solve? Yeah, but sometimes you can, and when it does work, it's actually pretty good. So just kind of keep in mind, if you see that x, you're not going to be taking a square root to do it. There are other ways to do it, multiple other ways to do it, which we will explore, but not this way. Okay, now what about this one? Okay, so this one looks like, okay, the b is 0. I don't see an x. I just see an x squared. So we're like, okay. So let's take a peek at that. So we could start by subtracting 8 from both sides. So yay. Okay, and then we divide both sides by 2. And so I get x squared is equal to -4. And here is where we're going to run into a problem. Okay, so I need some number that when I square it will give me a -4. Now remember, squaring means multiplying it by itself. Okay, you can't multiply it by something sort of like itself. So your first instinct might be, oh, well, I see a 4. That's the square root of that is 2. But 2 times 2 is +4, not a -4. So often when I do this in class, students will say, oh, well, then it's -2. Okay, but a -2 times a -2 is also a +4. And so you get to this point, and it's kind of like, oh, well, I guess like there isn't any number that when I square it, I can get a -4. And you would be sort of correct. I'm going to do something on my phone here and see if I can hold it up to the screen. Okay. This one it's not as much fun as the last one I did like this. Okay. So it's really not fun, but you can take out your phone, take out a calculator. Mine, I've got the square root. You guys probably can't see it. Find the camera there. Not that it's not even focused, but I tried to do the square root of -4, and when I hit equals, a little thing pops up that says can't show undefined result. Okay, so that's what my phone. Now, a previous phone that I had actually said it printed out the words "not a real number." Okay, but I encourage you, like, go grab your phone and see what it does. So it'll probably, unless somebody has changed a mode on it, and you have an advanced calculator, you're going to get some kind of like error message. It might say domain error. It might just say error. It might do something like mine said. But basically, we have a problem here if we want to actually solve this equation, because I don't have any way of getting past this point. So introducing the one, the only, the imaginary number. Ta-da! Okay, so we've been all year so far, we've been talking about like all real numbers, all real numbers, all real numbers. And I just have said, hey, if it's on the number line, it's a real number. So negatives are real numbers. 0 is a real number. Decimals and fractions, those are real numbers. Irrational numbers like pi, 3.14159. If you can get to a location on the number line where that number would be, then it's a real number. So when we're talking about numbers that aren't real, what we're talking about are imaginary numbers, which will lead into what are called complex numbers. Don't stress about the name. Complex numbers are actually very simple to deal with. They just have a complex name. But when we're talking about numbers that aren't real, this is what we're talking about. Not fake numbers. They're called imaginary numbers, and they're not on the number line. They are a totally new and different kind of number that's not on the number line. We can create a new number line that just has the imaginary ones on it, but we can save that for a future course. And so let's get into what this is. Well, it obviously needs its own symbol. None of the current numbers that we have are going to work, with this. So the symbol for it is a lowercase I. Now, typically when I'm writing it out, I will do like a little hook on the end of the I. That's to make it look italicized. So a lot of times when you're typing this, people will italicize it and they'll make it kind of look a little bit like that. All right. You will see when people are typing that they will just type a regular lowercase I, and that's just for convenience when you're typing. So typically if I'm typing, you'll see just a regular lowercase I. If I'm writing it out, I'll put the little hook on the end, and that's just to maybe differentiate it from like the normal letter that we would use. You can think of I stands for imaginary. Now, when I was in college in engineering, we actually used a J, and that's because the I was taken up by something else. Okay, now there's actually just one definition, but I'm going to give it to you two ways. So one way to define the imaginary number is this. The imaginary number is a number that when you square it will give you a -1. And you might be thinking, but we just said there wasn't any number that you could square it. Not any real number. This number is its own deal, not on a number line, totally different kind of number. When I studied these in high school, I got mad. I remember being mad about it, and my mom didn't care. She was a math teacher. She's like, I don't care if you're mad, you just have to learn it. Now, they are actually useful. So you're probably thinking, what on earth were the mathematician powers that be thinking when they made up this imaginary number? Like, they just didn't have enough numbers to work with, so they had to make up this one. And I absolutely understand feeling that way. You do have to trust me on this one that they are useful. They are used in electronics quite extensively. So they do have application. But I squared is equal to -1. The other way you could think of that is from the square root side of it. Where the square root of -1 is equal to I. Now, really, that's the same definition, just one of them is written with the squaring and the other one is written with the square root, but it's helpful maybe to look at both of them to just kind of see what, which one of these do you want to pull out of your hat. So how does that apply to some problems? So we're going to kind of go through 3 of them. What I will probably do is, because I have trouble writing on the screen and it's smaller than it is in class because of the mode that I have it in, is I'm going to write it on the screen give you a moment. You can pause the video if you need to. You can copy it down, and then I'll erase it. So for this first one, we have x squared plus 9 equals 0. So we're going to go about this the same way we did before, where we'll subtract the 9 from both sides. And as before, we're going to go ahead and take the square root, and we do need to put the little plus minus there. But now we have a tool for simplifying the square root, okay? So before, we would just kind of get stuck. Now, I need you to follow me here, all right? That is -1 times 9. Okay, I'll pause for a moment so you can just think. What'd she do? Oops. I should not be there. Okay. So can we agree that -9 is -1 times 9? I hope we can. So that's the square root of -1 times the square root of 9. But what did we just say was the square root of -1? Ah, that's right. We said it was I, and the square root of 9 is 3. Now, when there's a square root left in the problem, we will leave the I out front so that it doesn't accidentally look like it's under the square root. But if there's no square root left in the problem, then we would switch the order and write it as 3i. And that would be your answer. So x is equal to plus or minus 3i. In other words, we're getting an imaginary number for our answer. We're getting plus or minus 3i. So if you need to pause the video to copy that down, or just like pray over it, meditate on it, just kind of go over the steps to go ahead and do that. And then I'm going to erase it. And you can, of course, always rewind the video if you need to. So, okay. All right, next one. We've got -3x squared minus 15 equals 0. So we're going to go ahead and add the 15 to both sides. And we get -3x squared equals 15. And divide both sides by -3. And that gives us x squared is equal to -5. Oh, I love these problems. They're so much fun. Okay, I'm nerding out on this Thursday afternoon. All right, so we have x squared equals -5. So as soon as you see like something squared gives you a negative, we know like not a real number, but it is an imaginary number of some sort. And our mechanics go about the same way. So we're going to square root it. Remember that plus or minus. So now I've got x squared equals, not x squared. That's the second time I've done that. That is just x. My apologies. Plus or minus, and I'm going to do kind of the same thing. -1 times 5. Now, as you get experience doing these, you will not need to see the -1. Like the -1 is going to do the same thing every single time. It's going to like turn into the I when we take the square root of it. But until you are comfortable doing that, I am going to go through this process. So this would be x is equal to plus or minus the square root of -1 times the square root of 5. The square root of -1, though, we have now established is equal to this thing called I. Love that for us, okay? And the square root of 5, this time we actually can't take the square root of 5, so we just leave it as the square root of 5. So the answer would be plus or minus I root 5. And as before, you need to pause the video to stare at this, trace through the steps, reason it out, copy it down, whatever you need to do, go ahead and do that. And now I'm going to erase this one. I know there's like a way to erase all the writing on the screen. I use it accidentally when I don't actually want to erase stuff, and then I'm afraid to use it when it might actually come in handy. All right, last one. So 2x squared plus 16 is equal to 0. All right, subtracting 16 from both sides. So these all have a pattern to them. And, somebody was asking in one of my classes today, as you guys were taking the test, like, how do you get so fast? How were you able to do this test in 3.5 minutes? Because I do a lot of it. And you also will get faster the more of these you do. The first example always takes the longest, and then we speed up. So you can get quick at doing them as well. It might take a while to get as fast as somebody who's been doing it for over 30 years, but you can improve. All right, so we end up subtracting the 16, divide by 2. We get negative 16 divided by 2 is negative 8. And as before, we're going to square root this. And when we do, we just want to remember that we do have that positive or negative. Now, we have x is equal to the square root of plus or minus the square root of. Now, this time I'm actually going to break it up a little bit more. We haven't really covered simplifying square roots. Now, you should have had that before, but it is a kind of a forgettable skill that students usually don't remember. So I'm going to break this into -1 times 4 times 2. So if you want to kind of stare at that, -1 times 4 times 2 would indeed be -8. And you might say, how did you know to do that? Well, because again, I've done a bunch of these, and because I know that I can take the square root of 4. So I was looking for something that I could take the square root of. Now, as we go to write the final answer, we have plus or minus. The square root of -1 is I. The square root of 4 is 2. And then the square root of 2 cannot be simplified. The only notational change I'm going to make on this is instead of doing I2 root 2, we're going to do 2I. We're going to put that coefficient out in front of the I. So we'll have plus or minus 2I root 2. And there's your answer, plus or minus 2I root 2. So as before, you want to pause the video, stare at this, kind of trace through the steps. It might still be a little bit confusing to you, but try to hang on to as many of the steps as you can. So go ahead and do that now. And last up is our practice set. So solve each of the quadratics using square roots, or write that it cannot be solved using this strategy. So some of these you might not be able to solve. They are all similar to the ones that we did. Give it your best shot. Give it your best shot. This actually would be a great time if you use some AI. Not to do it. Okay, you're not going to use AI to do it. Like, you make yourself try to work it out, but then look at the AI to check your answers and check your work. If after you do that, you don't understand what the AI did, okay, so it's doing something and you're like, it's confusing. Actually, I would love it if you sent me a photograph, like take a screenshot of what, Photomath or Mathway or Symbomath or Gal, whatever it did. Take a photo of it and then send it to me and say, Ms. Taylor, I was checking my answers. This is what it did. Can you go over this? Because I don't understand what this is or how this is connected to what I did or did not do. Now, in the blue box, this is for fun, all right? Because math is fun. Curious about some other connections? Of course you are. This is not part of your homework. If you don't want to do it, or you've got like soccer practice, or you got to go to work, I understand. Okay, like give me the 10 problems to practice and you don't have to do this. But if you are curious, here's something a little extra to explore. In each of these, substitute a y, okay, in 1 through 4. Substitute a y instead of the 0. So it would be x squared minus 64 equals y, okay? So substitute that, and then go and graph them in Desmos with the y in them. And look specifically at the x-intercepts, okay? Look specifically. What do you notice about the x-intercepts and your solutions to the equation? So you've already solved them. Now graph them, and you should see a connection between the x-intercepts and what your solutions are. And then what makes number 4 different from the others in terms of the answers you got and or the graph's x-intercepts? Because when you solve it, 4 is going to have different kinds of answers. And then how does that show up on the graph? All right. As always, you guys know where to reach me. And I hope to see you guys. Well, I hope to see you in class, but if not, I'll see you in another video.